Welcome everybody to Sustainable River Basin Management Module 4.2, Part 1. Remember that we are still in our modules towards sustainability in river basin management, and we are starting now our second week. I want to now focus on planning in river basin management functions. Now, we will be talking about land use and water planning, because planning of both of the resources, land use and water resources, should take place in conjunction. Land use and water planning includes the mapping of protection areas, water protection areas, and we will be talking about this next time. Mapping of vulnerabilities and the assessment of risks, that's what we will be discussing right now. The water budgeting, and this should be based on realistic data and realistic forecasts, and climate proofing. Land use and water planning should also include a zoning plan based on these mapping exercises here and budgeting. The outcome should be a zoning plan, and there should be a license scheme based on these inputs here for specific land uses in what was identified as high-risk areas. And then we need an inventory of water supply systems and groundwater resources. Now, what we should keep in mind when we conduct this land use and water planning is that the planning horizon is usually quite long. We talk about 10 to 15 years in usual planning scenarios. We also need to keep in mind that we are not only talking about what is today and and keeping in mind the long term, that the exercise will take some time to actually come to a point where it can be implemented. But we also need to keep in mind that we have to exercise preventive measures also in terms of the protection of potential source water areas when we speak about water planning. And in some of the countries, this is legally enabled, that areas, as with the forecasts of water budgeting, certain areas can be preventively put under protection as potential source water areas. Now, let's look into an example, because we can talk about this very long in theory, and you may have a lot of examples in your own mind of how this has not taken anybody to any solution or any conversion of visible problems in your region. But there are examples of how this is working and functioning. And I want to show you one case specifically, which is the city of Dresden in Germany. And you can open this webpage and surf around yourself and obtain more information. So they have an information system that was built around the land use and water planning in this case. And they also departed from defining the objectives of the land planning. And this is quite comprehensive and could be a good example for other areas as well. So the objectives are to service or to serve citizens, investors, and attract visitors. This is applicable to many other cities as well. They have to serve their own people, residents. They also want to have investors, and they want tourists or visitors to come. The second is to enable living, working, recreation, and transport. This again are all the different dimensions of good quality life, of what brings people together and what makes people move to a specific region and settle there. It also should meet the existing and emerging needs, and it should complement each other and avoid disturbance. So this is quite interesting. Again, it's not just looking into what people today demand and what industries or some specific sectors want to see happening today, but there should also be wise view into the future, where some of the things should be predicted or be foreseen, and space for such emerging needs should be built in, facilities, land or whatever or is required to make space for these emerging needs should be built into the planning at this point, which is not always easy to see what the direction will be, as we have seen in one of the previous lectures on the water distribution systems and the investments made in Germany specifically, and then how migration patterns have actually negatively impacted on these large-scale investments. So it's not always to predict the right thing many years before, but we have to build it in. And we should secure the necessary land for the various uses. We should also bring together many different interests, and it should meet legal and professional requirements. Not all may see this as important to bring together many different interests. Sometimes we may just focus on one, on favoring certain industries, for instance, which bring along certain people, certain interests together. We could think of IT. The IT sector may dominate a certain region or a certain urban area. And then, or we could have only automobile industries dominating the entire land use, water use in a specific region. Or we could look into diversification, which is in this case what the objective of the planning exercise is. Now, how does it look in practice now? We have all the information compiled in a database which is accessible to the public. Anybody can go there and obtain information, can visualize the different components of the plan. This goes from geographical elements, physical, to land use, including emission, including disaster, including different industries, different water requirements. All this is here and is providing additional information once we click on any of these fields here. We can zoom in to a very detailed level, to a level where we can see individual houses, each individual house, and we can obtain individual precise information by clicking on any of these features here. Now this brings us to the point that information dissemination is very important when we conduct this planning exercise. One thing is to have good plans or several volumes of plans somewhere in shelves or somewhere with an expert group, which then will not be moving ahead to any implementation stage. Or we may put efforts into some form of information dissemination, and this could be one where anybody can make use to a level of scale that is useful for the individual, the household, or for planning a new business, to think about where you would open new branches, for instance. All this could be an information system providing you those details. Important here also is that this planning should include stakeholder participation. Also, this is possible here on almost any of these fields that you can open here is a feedback or request for more information function built in. This means you can, anybody who is interested, send a message out and contact somebody and obtain additional feedback, or ask for a meeting and get a detailed technical response to that. And this brings some level of transparency and also some level of accountability to the forefront. Once we know what the plan is here, we can also influence what we want to have happening in a certain area and what we don't want. And also we can visualize at an early stage and avoid certain speculation taking place and misuse of knowledge for land use and water planning. And also on the accountability part, we can actually follow up on what has been promised to happen in terms of improvements, for instance, in the city, and what has not been realized and has not been implemented to the date promised. Now, when we zoom into this, we can get to a very detailed level, and since we wanted to look into water specifically, I'm just picked here the details on dealing with water protection. We have here, even in an urban area, zoomed in now to this corner here of the urban area. All this is part of the city. The source water protection zones. This means that within the urban boundaries we have also water protection taking place. So it's something that is very much possible to set land aside and restrict certain land uses to take place in favor of protecting water for drinking water supplies. Now, here just to translate what's going on, source water protection areas are specifically mapped, and there are 3 different types of zoning categories which all appear within the city boundaries in this case to demonstrate this. Now, let's now move into the second point of the land planning that I mentioned, which are the vulnerability and risk assessments, and let's start with definitions. The general term vulnerability is the likelihood of an environmental or human system to experience harm due to stress and can be identified by a specified system, hazard, or a group of hazards. That's a very generic definition of vulnerability. Now, in the context of water management, we mean vulnerability is the tendency or likelihood for contaminants to reach a specified position in the water system after its release at the Earth's surface. And this is applicable to surface systems, but also to groundwater systems. And this is what we identify and assess by these vulnerability assessments. Now, hydrological systems are very special, and for that reason we also differentiate vulnerability in a slightly more specialized way. First is we use the term intrinsic vulnerability, which considers the inherent susceptibility of hydrological systems and is valid for every type of contamination as a result of human activity. And then we differentiate specific vulnerability, which considers varying transport processes of different contaminants. So one is looking at the contamination susceptibility as such, and the other one is looking at the processes which lead to the mobility or the impact of the contaminants by diffusion, absorption, or degradation processes. Now, in the case of groundwater vulnerability assessments, we assess the hydraulic inaccessibility of the aquifer and the contaminant attenuation capacity of the overlaying unsaturated zone. Those are the 2 factors which, if we narrow it down, characterize our vulnerability and are the most important intrinsic factors of finding options to protect our groundwater resources. There are many different methods of describing the vulnerability, and there are also different indices which were developed for different regions, different geographical regions, but also different geological regions or for different hydrological systems. For that reason, it will be hard to demonstrate you what generally is the method to take. I just want to show you steps to conduct a vulnerability assessment. The importance of the vulnerability assessment is that in general, risk management will increasingly become a core process in water planning. You remember that water projects fetch major budgets. Those are major capital investments which take place for the implementation of these projects, and this simply requires good risk management from all of the dimensions. The water planning has to meet environmental, economic, and social objectives. The activities and processes that put the objectives of such projects at risk need to be managed, and this is a preventive way of dealing with vulnerability. Such activities and processes could be, for instance, influencing water availability, reducing water availability, for instance, land use change, plantation, some monoculture, some urbanization, whatever the change in land use is, wetland removal, have an impact on our water planning and have to be assessed beforehand. And the impact on the planned objectives, for instance, in terms of water quality or in-stream and near-stream structure and information gaps, has to be understood and dealt with specifically in the form of preventive measures in our assessment analysis. Now, let's look into the generic vulnerability analysis, a summary how this is in a generic way be done to compose indicators of the hazard risk or the vulnerability of a certain system. And what we usually say is that the impact or the hazard risk is a factor of vulnerability and exposure. It's a function of vulnerability and exposure, and vulnerability and exposure could be brought into a simple relationship, and this can be expressed in the form of indicators or factors. This takes us to a source pathway receptor analysis, which is helping us to then take a decision of where we can influence and change individual components to a wanted outcome. Now let's move into an example of such a vulnerability and risk assessment. This is dealing with one of the aquifer systems of the city of Chennai in India, one of the shallow aquifer. And this was published in a study in 2013. And this is showing us here how vulnerability was determined. What are the input parameters to come up with a vulnerability score? Now we have here depth to water table, we have groundwater recharge, we have the aquifer media or the aquifer formation, the impact of the vadose zone, we have soil media, means land cover, we have the topography, we have hydraulic conductivity brought together here and brought together also in a weighted individual index. Now, the good part here is that we can use geographical information systems, GIS facilities, to calculate and reclassify the individual input components to be able to calculate an index from that. So we have here, for instance, the case of the land cover information. We have topography here, we have our soil types, we have the depth to water table here, we have conductivity here, and we have specific yields. If we had more information, more data, we could compile additional parameters here, or if one would be less reliable, we could eliminate one of these parameters here and still come up with a vulnerability index. And this was done for this specific case by calculating a vulnerability score. We have a range here from 4 green, so to say, less vulnerable, to red, dark red, a vulnerability score of 8, which would be highly vulnerable. And then we have here what the geographical extent, the spatial extent would be of these vulnerability components. So what we could see here is that the beach line here, you should know that this is the Bengal here. This is, so to say, the beach line here. This is coming out as a highly vulnerable area. And then we have here a few rivers or drainage lines coming in, which also scored fairly high in terms of vulnerability. So this is something that is a feedback into our land planning, into our land and water planning exercise, which can be in this way put onto some standard or some methodology which enables a cross comparison with other regions and with other adjacent areas of the area of interest. So this is very powerful, very useful. In this case, we can we also, besides to the vulnerability, the natural vulnerability, we have our exposure component, which are all of these, the human-induced sources of contamination. This was compiled for just one suburb, not for the entire area that we have seen here in this map. But those can be included and built into the risk index, such as the chemical industry, oil storage tanks, rubber and tire industries, and so on. And we can see where the location is. We can give each of those a certain weight. We can calculate a hazard index from that and determine a hazard index level to that. Now, where do we take our weight from in this specific case? This would require some expert inputs, some community or group or focus group discussions, where some local knowledge, expert knowledge, is being built into how relevant, how apparent some of these exposures are, and in what terms they can become a risk to the water resources. Now, this is just an example, and any other location could be dealt with in a similar form, however similar only. Now, you should take this home and revise this specifically about risk and vulnerability assessments in your region, and see how specifically which type of data were incorporated into these assessments and how these the indicators were computed. Were there any expert consultations conducted? Did stakeholder consultations take place? And what you think the usefulness of the outputs are from your point of view. Thank you for your attention, and I see you next time again.